All right, so welcome to a very interesting session that we're going to talk about today. I have with me on the mic Farah Papaioannou from EdgeWorks. I have as well Ajay, Nair, and Kilton, as well as Todd. Just a little introduction. So today, the talk title is going to be about production ready EdgeAI with Eclipse, ioFog, and Google Coral. And just a short introduction about Farah. Farah is the president and the co-founder of EdgeWorks. EdgeWorks is an edge computing company, pioneering open source universal edge computing platform with Eclipse ioFog. Farah is also at an early investigating in Silicon Valley and DC venture capital firms. She holds 3 degrees from Stanford University. She graduated with Bachelor's of Science and Honors in Computer Science, and a Master's degree in Communications and a Master's degree in Management Science and Engineering. Farah and her husband, Todd is with us on the call, have 3 kids, including a newborn. Congratulations, Farah, for the newborn. She loves skiing, traveling, and getting full night of sleep whenever possible. So good luck with that. I have as well with me Ajay. Ajay is product evangelist and at Google and for edge machine learning solutions, and also an industry expert and University of Berkeley graduate. I've also Kilton Hopkins. He's the co-founder and CEO of EdgeWorks. Kilton, by the way, started programming computers when he was only 8 years old. That was in 1986. He started a software company a few years later that worked in a very different, as he says, the world is very different today than it was back then, but Kilton is still bringing new tech companies to life. Kilton is a University of Chicago School of Business graduate, and he likes to meditate, make music, and read about everything scientific. Before I move on the mic to you, Farah, Ajay, Kilton, and Todd, I'd like to bring to your attention that there will be 5 to 10 minute session by the end of your talk dedicated to Q&A. I'll be bringing up all the questions to you, and wish you all the best. So mic is yours.
Thank you. Thanks for the introduction. So today we're going to talk about production-ready EdgeAI because who doesn't like to take things to production after working so hard on your test and dev environments using Eclipse, ioFog, and Google Coral. So we already went through introductions. Just a quick update to my bio. I now have 4 kids and a lot less sleep. So we're going to move forward to our talk here. Ajay.
I work at Google in their research group called Google Brain externally, Google AI internally. And we are focused on bringing machine learning solutions to the edge. And we'll talk about what that means and why the edge is important. But to step back a little bit from there, we started the journey on machine learning at Google way in the past 10 years or so, where machine learning is really important for various internal Google applications. We think of search, visual search, shopping experiences, live translations. All of those needed a lot of machine learning infrastructure to be able to run training and inference internally. And to enable that, Google needed to have high compute available in our data centers. And the compute that was available in the form of CPUs or GPUs required the data centers to grow at a rapid pace just to support the requirements in ML compute. And it was not scalable because a new data center costs billions of dollars to make, a lot of time. So we stepped back and said, how can we make existing data centers more efficient for machine learning use cases so we don't need to keep adding data centers at a very rapid pace? So we went back to the drawing board and created machine learning hardware from the ground up. It was called the TPUs, for Tensor Processing Unit. And it was very well received. A lot of good internal use cases. And then we externalized that to customers for their training and inference needs as part of cloud TPUs. So where you could rent TPU space and run your inference and training algorithms there. That was successful, but customers came back to us and talked about the edge. And very broadly, what we say what we mean when we say the edge is anything outside of the cloud. So it could be on-prem servers, on-prem racks, gateway devices that you have in your environment, or even end nodes such as cameras or sensor level devices. And how do we get machine learning into all of those devices? And the reason customers asked for machine learning capability in these edge environments is what we're listing on this page, is around privacy. The first one is around privacy and compliance. Especially if you think about video data where you have cameras looking out into public spaces and capturing information and video streams that contain recognizable or personally identifiable information, or as it's called, PIIs, right? In most use cases, the owner of the camera installed does not care about the PII. If you think about a retail store, for example, they might want to see how many people are in the store at a given time and how are they interacting with their environment. They don't really want to know who you are and any personal detail. But in an existing scenario, those cameras are actually likely streaming and capturing all of your video information either locally or streaming to the cloud for long-term storage, which is a concern for privacy and soon would probably be an issue for regulations in various parts of the world as well. So if you actually just need to extract metadata from that video stream, why do you need to stream all of that video information? So by running inference locally, you can collect information such as how many people are in the store at a given time, or what are they doing by running pose estimation models. If you look at the right of the screen here, the picture that we have shows people in an environment, which is actually from a live video. It just masks out all the people. So there's no PII that is transferred into cloud. All that goes to cloud is how many people are in your frame and what are they doing. So that's one use case. The other was around fast response time or latency, reduced latency, especially important in manufacturing and transportation. The example on the right is in a transportation example where a camera is looking out at different lanes of traffic and trying to identify cars and assign accuracy to it. If you think about a manufacturing line where you have to detect a defect, let's say in a beer bottle manufacturing plant where you want to identify a defective bottle and take it out of the manufacturing process, those lines are moving at 20 miles an hour. We have very little time to identify and correct those issues. So latency is very important. The other is need to be offline. So not every use case can rely on an always-on connectivity. Think of third world countries or installations such as in oil refineries, windmills, out in the desert where you don't have connectivity. So you want to be able to run inference locally without an always-on connectivity. The other is an overall reduction in cost, which comes primarily from reduction in bandwidth. We talked about the video example earlier. If you're taking a video stream and streaming it to cloud, you are using a bandwidth, which is very important these days for other applications. But once you get all of that data into the cloud, you have to pay to store all of that data. And then to extract useful information, you have a lot of data that you have transmitted that you may not have needed in the first place. So searching for information in all of that data is sort of like sending your, a haystack up through the cloud, paying for transportation of that haystack, and then searching for a needle in the cloud. Why do you do that in the first place? You can actually trim down your data by sending only useful parts of the frame of the information to the cloud, and then it's very rich in data, and it makes it very easy to extract information out of that. And of course, security, privacy, and lower cost of the actual hardware in terms of power, in terms of physical footprint was important as well. So several reasons, and listeners in this call might have other reasons why EdgeAI is important, but these are the reasons why Google said, we need to step in and look at solutions for edge machine learning as well. So if you move on to the next slide. So to address those needs, we came up with another chip that was designed within Google ground up, but focused on inferencing at a very small power footprint. So what we call that is the Edge TPU. It's a custom-built ASIC for and with a performance of up to 4 TOPS and half a watt per top, so up to 2 TOPS at peak performance. So that's running at full speed in worst case power profiles, but typically you would expect sub-watt performance on those. The table that you see on the left is running different types of neural networks on the Edge TPU and the kind of speed up that you would expect versus running it on a classic Edge CPU. In this case, a quad-core A53. As you can see, the different model architectures give us performance improvements of between 50 to 1,000x, depending on how optimized the models are to run on the Edge TPU. And the numbers here, by the way, are latencies in milliseconds. So we're very excited to bring this chip out about 3 years back. And if you move on to the next slide, we introduced the Coral platform, where and that's how we bring out the Edge TPU to the market, and we want to address customers and users to be able to go from prototyping to production. The reason Google is doing this is because we think ML has a lot of potential, and that potential can only be realized by lowering the barrier to entry in terms of cost as well as technical capabilities in these devices. And we do not want to complicate things by having different paths of going from prototype to production. So we have the same Edge TPU, the same OS, the same drivers that help you go from prototype to production. And Farah will talk about how EdgeWorks is helping in that transition from going from prototyping to production using their platform as well. But overall, the reason why we're doing Coral is we want to bring all of those advantages of machine learning in different industrial verticals. We are focused on researchers, students that are learning ML, as well as practitioners in the industry in several verticals, namely manufacturing and transportation, healthcare, agriculture, and smart cities. Essentially, the way we think about it is that if you can look at something and take action on it, or hear something and take action on it, it can be optimized with the use of machine learning. And so that's our goal here. If you move on to the next slide, we recently introduced a partner program with Coral. And the reason for that is we feel that even though we are enabling machine learning at the edge with the infrastructure that we bring to the table with the Coral products, we can't do it all alone. Our mission is to create a society where we are able to provide use cases that enrich lives and strengthen society, but do that in partnership with an ecosystem of customers and users, as well as the overall community. To that goal, we introduced a partner program a couple of months ago with the goal of opening up use cases that are enabled by the use of Coral. And we have partners in either hardware partners that provide solutions, production solutions using Coral integrated in them, software partners that provide end-to-end stacks, so a software stack for connectivity, or model developers that help write machine learning models for specifically Coral. And we have distribution and service provider partners to help customers scale up with the Coral devices. And EdgeWorks is one of our close partners, and they have multiple parts of this the stack on hardware as well as software. And we are really excited about how they are helping bring Coral to the community and bridge that gap from going from proto to production very quickly. And Farah will share some more details on that part of it. Farah,
very excited to be a part of the Coral partnership, because we believe it embodies the philosophies of the Eclipse Foundation, particularly as it relates to Edge and the Edge Native Working Group. I think one of the things that's really held back Edge is this viewpoint that open source community and projects have had, that their project is the one and all, and that one project to rule them all, so to speak. And the Eclipse Foundation and the Edge Native Working Group in particular believes that, like other disciplines that have come before us, cloud, big data, AI, it's not going to be solved by one project, but a cooperation of all different pieces and parts working together. Just like in the cloud stack, there are many different components and pieces that make it all come together. And so I think that coming together with the Google, bringing the Eclipse Foundation into that is very exciting for that reason. Next slide. So one thing we can all agree on is developing for the edge is hard. And the real driver for the edge, as Ajay has talked about it, has been video. The amount of data that has been generated over the last couple of years. And I've been chasing data my whole life. I started off at 17 at a storage company, or I guess 19, Hitachi Data Systems, and I've been chasing data. And in every company that I've worked at, what we've realized is data is going farther and farther outside of the back end and outside of the cloud, but more into the world. And you can see that in the proliferation of devices. And the data du jour is video, the ones that, my kids don't really even touch text anymore. Everything is shared via video. And so, that's really been the driver for the edge. And it's an entirely new environment, and cloud developers are trying to get to that, to amass and leverage this very rich data set. And what makes it different from the cloud? Well, in the cloud, you have, developers who can, specifically focus on AI. You have developers who can focus specifically on like DevOps. At the edge, you require them to do all of that and more. So, developing edge AI models is difficult, right? And one of the reasons why we're, excited to be partnered with Google is, they have a good ecosystem around TensorFlow, and that's a community that we can draw upon. Deploying and managing multiple applications at the edge is very difficult. It's one thing that the Eclipse ioFog project is looking to address, but it's not the only component. It's definitely something that's needed in order to run in production. When you're running something locally, you can kind of see what's going on there. When it's out in production, you need a way to deploy and monitor that. So you need to be both an AI developer and you need to be an edge ops expert. And then, unlike the cloud, where you don't even think about hardware, there's a bunch of servers sitting off somewhere, and the deployment is largely the same. There's an overwhelming array of hardware and edge hardware and edge AI accelerator choices to be made. So now you're asking like a developer to learn AI, become a DevOps, edge ops engineer, and have experience in hardware, and that's very challenging. And so those people are very rare to find, if any, and or they have to learn these capabilities over time to be able to begin to like work at the edge. What we're trying to do is kind of bring that all together and make that easier, so you don't need to become an expert in all of these domains, and try and make that mimic the cloud environment as much as possible. So you could take the 27 million cloud developers today, and that number is growing to like 40 million, and enable them to become edge AI developers. So the glue that holds it all together, the Eclipse ioFog project. And why is Eclipse ioFog important? I'm not here to say that Eclipse ioFog is going to be the panacea that solves all of the problems that are needed for the edge, but I believe it's a necessary component in order for us to solve one part of the stack, which is the edge ops piece. So what it enables us to do is deploy, monitor, manage not only single devices or an entire fleet of nodes at the edge. When you have things in development, you can have them connected to your laptop and see what's going on. But when they're out in production, when they're sitting on a factory floor, when they're out on on an agriculture field, when they're out in an oil field, on a school, in a hospital, they're not in our hands anymore. And we have to be able to deploy applications to them, make changes to our AI models, add on new AI models, and see what's going on both with the nodes themselves and the applications that are running on top of them, and have the ability to continually deploy. One of the benefits of the edge is that like the cloud, you get to decouple the hardware from the software. So the edge software and hardware don't necessarily need to be bundled together to be a full stack thing, and that the only way to update software now is to add on a new piece of hardware. That world is like passing us by. We need to be in a world where we can continually update software and not necessarily have to change out the hardware, because people are okay in adding new software. No one likes to change out their hardware. Runtime deployment and orchestration of distributed microservices applications. Again, this is very core to the Edge Native Working Group, which is to kind of mimic the cloud native paradigm of using microservices. And so enabling that orchestration is key to ioFog. And again, we integrate with Kubernetes to make that all seamless from cloud down to the edge. And again, there is a wide variety of edge nodes out there, from dev boards to production boards, and we're going to show a demo of how do we move from one to the other today. But ioFog allows us to abstract all of that different hardware out there to make the runtime environment look exactly the same, whether you're running on a Raspberry Pi or on a colo data center. It should all look the same. So we can run code at the edge, but control it like it's in the cloud, and that will enable cloud developers to really embrace the edge the way they'd like to. So how are we getting to that place where we can get this faster edge AI development? I'm not necessarily a developer by nature, but I spend a lot of time in the edge ecosystem. And I can tell you from experience and watching people bang their heads against the wall, even in today's environment, it's very difficult to get AI down onto the edge. You have to flash OS systems. It takes days. You have to connect, to a modem by a serial cable. And even once you get, you go through that pain of getting your edge board stood up, then, you'll deploy your AI model, and then what, right? You'll see the, logs spit out onto the terminal window. But what does that mean for the real world? There's no real next step from there. And so, we've been working together, the Edgeworks and Coral to make a seamless transition from development into production, because that's really what we want to do. We're not like developing AI models just for, development's sake. We really want to solve real world problems. And so, how do we do that, and how does ioFog kind of bring that all together? So, we're going to show a demo of this, but really what we're trying to demonstrate here is that using ioFog, we can take something that's running on a Coral dev board and deploy it onto a node that's sitting out in production. And so we're going to leverage one of the production environments that we have out in the world today, which is the Darcy node. It has a compute, dual Coral AI accelerator, a vision, audio, and thermal sensor, all in a packaged enclosure, and show that, hey, as a developer, you can have your Coral dev board, you can tweak AI models, and when you're ready, you can leverage ioFog to orchestrate those applications down to the edge into some production environment. We have some production Darcy's now sitting in schools, hospitals, and workplaces. So, hey, if I want to add a new AI model today, because a school last year wanted to check for masks and temperatures, but a school this year wants to check for can we detect weapons? Well, we can, develop that AI model. We can tweak it onto the Coral dev board, and then when it's ready, we can say, hey, let's take this, leverage ioFog, and then just push that out to production. So today we're going to show that demo and then see this actually thing out in work, and that's really where we want to get to. So next. So I think, yep, let's get started here with the demo. Todd and Kilton are going to demo the showing the Coral AI microservice deployed down to moving into the Darcy to the point so that ioFog can not only do the orchestration of those devices, but help manage a fleet of those devices. Because usually when you have a board out in production, there's not just one. There's going to be one going to 10, going to 50, going to 100, going to 1,000. And that's when you really hit success as a developer.
Yeah. So can everybody hear me okay?
Yes.
Okay, great. So what we're looking at here is something that we're really exciting to be showing at this conference because this is typically where we show new stuff with Eclipse ioFog year after year. And what you're looking at is some early access to the new ioFog 3 components, features, and look and feel that are coming out. So what's in front of us here is what we call, it's a user interface view of what we call an edge compute network. The concept of an edge compute network is that you have various things that are working together. They could span the entire globe. Maybe they're one city, maybe they're one factory building, but it's a logical concept of how you bring together different things to work together under a common task. And so you could have 20 edge compute networks that are under your care, maybe each one for a different fleet of vehicles or something. How they're grouped together is up to you. And so this view allows you to see everywhere on the planet, all of the edge nodes that are working together. And yes, they can also be nodes in a data center. So your edge to cloud is a seamless continuum, and they all stitch together to make things work. Well, we've got 2 of them here, kind of fulfilling the promise that Farah has described, which is really also what Ajay has described as the goal of doing the compute at the edge, or the AI inference as the edge, is be able to accomplish something and then go put it to work. The 2 nodes that we have is we have one of these Coral dev boards, and then we have one of our pieces of Darcy hardware, which, as we discussed, is kind of the production-ready camera that's got the corals in it and everything. And those 2 are the only 2 things that I have in this ECN, or Edge Compute Network, for purposes of demo. And so if you take a look at what's in the Coral dev board here, we start to get stats about how is that board doing and what does it contain. So what's been in ioFog from the start is understanding, what is this edge node? What architecture is it? And how does it run? How much RAM does it have? Are we running out of CPU availability, or are we doing really well? How much storage space, and so on and so forth. But new for ioFog 3.0 is also identifying additional resources. This is very similar to, in the Kubernetes land, the custom resource definitions, or CRDs, which is you add some additional stuff that's available on each of the nodes. Well, our version here is called Edge Resources. And this all being open and open source is you can expand this. Look, we see that there's a Coral. And if we quickly look at the Darcy unit, we can see that that unit has 2 of them. So edge resources is just like saying, if I'm going to orchestrate intelligently, and I want to push out an application to the edge that needs Coral for AI inferencing at the edge, I'm going to push to units that have that available. So edge resources, new to ioFog 3.0, very exciting. And it allows for really deep orchestration where you're aware of what the edge environment has, and you can make decisions about what to push down based on all of that. So what we're going to do is we're going to run an application, a simple demo application, on the Coral dev board. And then we're going to see that run. And then I'm going to show you what migration production looks like. But let's take a look at that actual application that we've got running there. Everything at the edge using Eclipse ioFog is infrastructure as code. And so we're going to drag a YAML file out onto the board. And so then what we get is a view, this YAML file, and you can see here that it's queued. So this is going to get queued, and then it's going to get, if they need an update to the microservices, they'll get pulled, and then they'll start running, and we can see all that status right here from the UI. And so if we look down at the YAML file here, we can also see Farah's cat, which I love that cat. And I love doing conferences this way too. It's a lot of fun. So we can see this YAML file is pretty straightforward. It's pretty simple. This is the concept of infrastructure as code, which is, this is if you're in the cloud native world, that's a mantra, right? It's infrastructure as code. No longer are you logging into servers to stand up software, right? You just have a definition and you deploy. There's a YAML file for ioFog, which allows you to do infrastructure as code for the edge. And what we've got here is we've got a single microservice that we're putting out there and deploying, and I can see that it's running. So the status got updated in the background here. Fantastic. That's all I need to do in order to work with the Coral dev board. And I could easily pass this ECN, the credentials to team members and allow them in, and they could deploy. In this scenario, you can actually have 50 Coral dev boards if you want in a little farm for doing testing and deploy all these different model options and which one's working best and so on. And all of this becomes possible because you're no longer just putting a board on your desk, attaching a USB cable and saying, let me work with it, right? And this becomes a real, it's just like cloud native except for the edge, it's edge native. So with this thing running, let's take a look at what on earth is actually running. Well, all we have to do is open up the browser window. And so we've got the Coral dev board pointing at Farah from right behind her laptop. And you can see that the inferencing is happening in real time here. And so we're capable of a huge amount of frames per second here. And as Farah holds up her cell phone, we see her cell phone is a fed person and so on. And we're running just one of these demonstration AI inferencing models, the same type that you would run, and any TensorFlow Lite model that you would run to try it out. And so what we're showing here is just kind of like a simple web UI. And so I'm grabbing frames at maybe 1 to 2 frames per second. in our tests, we're getting tens of frames per second capable on the raw machine, if not even higher. This is incredible inference performance. Here comes our cat again too. And look, oh, it identifies it as a cat properly. I love it. This is perfect. I don't know if our of you trained her for the demo here, but it's doing a really good job of helping out.
She has done some hardware testing for us, that's for sure.
That is absolutely true.
Boards off and seeing how they react.
That's right. This is like endurance testing for edge hardware. And so
I
this
must
is running on
say,
the Coral Dev board. Yes, go ahead.
I must say that's a beautiful cat, Farah.
Puppy loves like testing the Coral Edge board. Just knocks them off and sees how durable they are.
Yeah,
amazing. Carry on, please.
All we need to do now is train an AI model that can judge and assess the beauty of cats, right? And
then I guess that's the next project. Yeah,
so good. So this is running on the Coral Dev board, and now normally, let's take stock of what's happening right now. Normally, you can get that type of demo running by attaching that edge board to your, to your USB cable and getting in and then you SSH in and so on, right? You can do all this. You can stand up a demo. That's usually where you end. Because what you have at that point is you have an understanding of how to do the AI inferencing on the edge board, how to tap into the AI accelerators. This is all good. But where do you go from there? If I want to then proceed to say, I built something that works great and I want to put it out in the world, you're looking at a development kit. And what you need to then undergo is an entire industrial design process to figure out, what am I going to put out in the world? You're not going to put edgeboard dev kits unless you're going to put an enclosure around them. And then you're going to find, you need to attach a camera. What do you do for the power? What do you do for the connectivity? And if you don't have Eclipse ioFog, what are you going to do to even work with it once you give it to your customer? So let's say, so Ajay mentioned retail and understanding what people are doing in the store. This is a great use case. You get all your stuff right and it's sitting on your desk and you're like, in my test environment, this is great. You go and you give that to your customer, they power it up in their environment and you'll never see it again. How do you connect to it? You're not on their network. You're going to hang out in their store all day. You need the edge infrastructure, which is why Eclipse ioFog exists. And honestly, I think it needs to be open source because we're all building it stronger together. But you need this edge computing infrastructure so that you can move out into the real world and still be able to get into it and do things with it, which is exactly what we're witnessing here. Now, if you're going to then build some edge device that you launch, such as a camera that has a Coral AI accelerator in it, you're going to undergo something like a 1-year process. It's going to cost you $100,000, quite possibly more, depending on what you're building and so on. And then you're going to have to figure out how you do all of the management and so on once it gets out there, and how do you get the connectivity and all that. We are seeing right now, we're at the flux point. We just did a demo on the dev board. Where does it go? So let's take a look at deploying this to an actual production Darcy unit, which we have in our ECN here. We're going to deploy the exact same application. And the only thing that we're going to change is we're going to drag the YAML onto this node instead of the other node. So this is going to get queued up and it's going to start going just like we had for the dev board. So we'll watch it go from queued to, to pulled to starting to running, and then we'll go check it out. This process means that you really only have to ask the question now, how many production pieces of hardware do I need to solve my use case? My dev board in the lab was 1. It's running already, which is really awesome, by the way. So we'll pull it up here and let's take a look at the stream coming off of this one. So this one is down the hall, and it's the exact same application. It's just on a different camera, which is in a different part of the household. And so thank you, Farah. So Farah's going to show moving from where she was looking at the other camera into looking at this one. And off we go. Same exact code. Except this is running in a unit that's got, it's awesome. This is in a unit that's got 2 corals, thermal camera as well as a visual camera and all of this stuff. But the question now just becomes, how do I move to production? Okay, well, how many production cameras do I need? If you've got it on your desk and you do this retail analytics application, you try it out on one dev board, and then you say, okay, well, my customer needs 20 cameras in order to cover their entire showroom floor. And so, and what Farah's holding, by the way, is what a production Darcy looks like. This is what you would buy 20 of or whatever. And so the idea is that you just say, I built it, it works, and I want to move it into production. How many units do I buy? okay, I'm going to buy as many as needed for this deployment. And the process that you use, so it's kind of like a little Vanna White kind of showcase here, right? It's like, thank you for holding up the Darcy cam. How many do I need to put it out there? And then the same infrastructure you use to move through development is what you use for production. And this is like the cloud. It's exactly how we do the cloud. You don't have some cloud dev environment in which everything's different. You have to figure out how to make it run in production cloud. You have a dev environment, you have a production environment, you push it over there, it should work. If it doesn't, you probably did a bad job of building it, right? Or at least it's, the wrong cloud infrastructure. Edge should be like cloud, just like that. So that was a major move forward in a very short amount of time. And let's talk about the developer experience for building AI for the edge. And when you do it with Eclipse ioFog and what life is like. You want to build the part that's the business logic. You want to train the AI model to do the inferencing that matters to your use case. Do you really want to write code that's all about moving data from this edge board up to your cloud environment, and what happens if you're not connected for 20 minutes and so on? That sounds like a universal problem. Solve it once, never have to solve it again. That's what edge computing infrastructure is for. That's what Eclipse ioFog is for. Do you really want to focus all of your time on figuring out how to manage that edge board and reboot it remotely and see if it's running out of RAM or anything like that? No, you want to just move on to the business case. Helping you build computer vision is going to allow you to solve real world problems faster. And then being able to move them out to production at the click of a button with edge computing infrastructure, that's going to help you solve real world problems faster. I personally believe that we're at a fluctuation point where all of our learning about AI and ML and edge computing and computer vision and sensors and how to do edge boards at a low cost and use very little power so you can deploy 20 of them, it's all converging. And we're coming into a world now where using computer vision and AI to solve real world problems, even if it's just for 5 people, you can do it quickly and you can do it effectively, and you don't have to do a $100,000 one-year project in order to make it come to life. So that's the gist of what I wanted to show here. And so I think, and then, yeah, so actually, since we have the time, what would you build from here on out? So that was a little demo. Let's take a look at a production real-time AI application that uses the Darcy cam, which uses 2 of the Coral units together. So please meet Darcy. Darcy is saying hello here. This is built with Eclipse ioFog, with the Google Coral for the AI acceleration, and the same camera we just demoed the demonstration on. Farah's going to approach. The Darcy cam is going to take her body temperature. So this is scanning. She's at 98.8. She's not wearing a mask, but when Farah puts on a mask, Darcy will say, please do, right? And so then it'll adjust, face mask now detected. And so then Farah is able to anonymously check in by showing a QR code, which includes, in this case, a COVID survey, which is very relevant for going in and out of retail spaces and churches and schools. That was pretty easy. What's going on behind the scenes? You've got TensorFlow light models executing on the as I said, 2 dual Coral modules. That allows us to do multiple AI inferencing in the same frames of video coming through. And we like to keep a frame rate of 10 frames per second or higher because you're interacting with Darcy. This is real time. It's actually really close to robotics. Darcy doesn't have arms and legs, but she's got eyes and ears and even thermal eyes, so she can read your body temperature. You have to interact very quickly. And one of Ajay's points earlier was why edge AI versus AI in the cloud. You will never be able to stream video to the cloud and get answers back fast enough to interact with somebody at 10 frames per second or faster. You just can't do it. They're standing in front of the camera. They are not going to wait for 2 or 3 seconds to see whether it thinks you've got a face mask. It needs to judge immediately. And so Darcy was a great way for us to show off what all these pieces together can do. And what's happened now is not just helping out with COVID. Darcy is graduating to allow you to build with Coral, then move and push that application into a production Darcy cam unit and use Darcy to solve all these other problems, not just people checking in for COVID. So the graduation is, congrats, Darcy. You have moved from the solving one problem to opening to solve the rest. And it can only be done with the open source edge computing, the ioFog, Eclipse ioFog, and the Coral AI acceleration. These pieces are all needed together. So I think that ties it all. And right on time, I think we've got some time for Q&A. And I'm seeing some comments about how nice it is to see a demo that doesn't fail out. Yeah, that was great, and we even had Jet helping, which was really awesome.
Great job. Really, you rock it. Again, it is a very solid proof when you're running live demos, and they really do not fail. They really show the level of maturity of the solution, and I must congratulate you on behalf of the foundation, the rest of the team, on the amazing work EdgeWorks. So just before I move on to the questions, and I've got few moments to raise some questions. So we've seen the ioFog announcement last month, and someone might ask, shall we be expecting an ioFog 3.0 soon? Maybe.
Oh yeah. In fact, we actually finished, and it's in alpha right now. And Kilton can talk about some of the really cool new features coming out in 3.0. So thanks for teeing that up there, Clark. You read my mind.
So
amazing.
ioFog 3 is in alpha right now, and it takes a while to reach the point of where ioFog 2 has reached, which is we're solid. It's all out there. It's been battle tested. It's an alpha, and it'll be moving to beta fairly soon. And if you are on the ioFog project Slack channel, or you go on the discussion board, you'll probably already have seen people ask, can I get it, and so on. Yep, just ask. If you want to get in the alpha program, we can give you the newest, latest, and greatest stuff. Eventually here, we'll be announcing when we're going to move into public beta. I'm not sure if that'll be within a couple of months or more like end of the summer, but we'll be moving there soon. You'll see those announcements. And then, of course, as that moves forward into the full release, you'll probably already be hearing about ioFog 4 or 3.5, whatever it is we have coming out at the same time that gets into full production. So we keep rolling and rolling. And yep, 2 is what's that for?
Do you want to give a little sneak peek to the audience about what's coming in 3.0 before we announce the cool new features?
Yeah, so you've got what you saw today. You saw Edge resources, and you're also going to get the improved UI that which is ECN Viewer. That's the UI that ships with Eclipse ioFog, and it's getting a facelift and more opportunities there to do things like drag and drop deploy and the little tricks that we saw. It's you got to view stuff in ioFog 2.0, but in 3.0 you get to actually interact and do some management there, and everything's more streamlined. And of course, we have all types of enhancements to speed and so on. You have better reporting of what's happening with the Edge microservices, so you see them rapidly. You saw it go from queued to pulling to starting to running. And all of that is so fast that before it would have gone from queued to running by the time you got a report. And now it's, you see it. We'll even tell you information about how long you're going to need to wait for the Edge microservices to maybe load and download. It's really cool stuff.
Variables.
What's that?
The environment variables. You change them on the fly. You could change the environment variables.
Yeah, and with new deployment options, right, you can actually fine tune an Edge application just by saying, let me update this, and then boom, we'll make the changes for you. Exactly. So the management is really key in ioFog 3.0, a lot more management options and just faster response to making changes and so on. And then you have the ability to use application templates now, which is, I'm going to build a template. I'm going to pass it to you, Farah. You're going to deploy it. You're going to add your parameters into it. But you don't need to write your own YAML. You just need to fill in the blanks. And that is a really great concept for being able to take something out of development, and then you have the same template, but for production, you have different keys or values. It's very good to do there. And so if we scroll through the what's new on this too, there's Edge resources we talked about. And so then there's also the ability now to define for yourself your own environment. Let's say you're using Mint Linux on a board that you've never used it on before, and you're just giving it a whack, and you find, oh, the default installer is not updated yet. Don't wait for a patch. Join the community, write a plugin, and post it back and say it now works on Mint Linux on this Rock Pi board or whatever it is that you bought that you're trying out. So. Yep, ever expanding the community involvement here. So I think it's a pretty good summary of what we've got coming in 3.0.
Amazing. Amazing. So stay tuned for the announcement from the Eclipse Foundation, IoT and Edge Working Group, as well as EdgeWorks. One follow-up question, Kilton, from Shant is, he was wondering if the dashboard that you were showing is part of ioFog, or it's mostly the command line utility.
Yeah, I just answered in the chat, but I'll answer it verbally too. So okay. The Eclipse ioFog project comes with the core controller, which has APIs. Then it comes with the ECN viewer, so the UI that you saw, which uses the APIs. Mm-hmm. ioFog CTL, a command line that uses those same APIs. So you can choose command line, you can choose the UI, and it's up to you. And they work in tandem, or you can use each one of them individually and just focus on one over the other, but they're all part of it. Yep.
All right. Sounds great.
Do you have any more questions before we sign off?
I think those are the questions are all raised and answered. So I wanted to thank you, Ajay, Farah, Todd, and Kilton for the amazing session and the demo. I must have said, the demo has been amazing, and it could raise to be said, demo of the year probably, but that's an amazing work. So wonderful presentations, some of the feedbacks we're getting from the folks. So thank you for the compliment, and yeah, please feel free to reach out to Farah, Kilton, and the EdgeWorks team, either on Slack channels or straight to their email addresses. In all cases, I'm gonna give you around 10 minutes to break, stretch, and prepare for the last session of the day. The last session of the day is going to be, very interesting session with Sedida. We have Jason Shepard, VP of Ecosystem, to talk about, extending Kubernetes to the distributed edge of Eve/OS. So stay tuned for this session. Thank you again, EdgeWorks team, Ajay, Google. Thank you for the amazing session today, and speak soon.
Thank you.
Thanks a lot. Bye.
Thanks, everybody.